Hello, this is a project for Management 6710 Strategy and Technology. This is a technology update on enhanced geothermal systems by Terrence, Brittany, Shani, and Jordan. I'm Brittany and I'm here with Terrence and we'll tell you a little bit about it. So Terrence, what is geothermal power?
Well, Brittany, geothermal power is a power source that uses the heat from the core of the Earth to produce electricity. The core of the Earth radiates heat outward from radioactive decay and frictional heating caused by denser materials sinking into the center of the planet. Here's a little diagram showing the temperature by depth.
So how do we actually get electricity from heat?
Great question, Brittany. Here's a little video that will give us the answer.
The natural heat of the Earth creates geothermal resources. This heat comes from molten rock called magma, located at the Earth's core, deep below the geothermal resource. Over thousands of years, rainwater seeps through cracks in the Earth's surface and collects in underground reservoirs. The magma heats the water until it becomes a superheated fluid. To reach the superheated fluid, wells are drilled 5,000 to 10,000 feet below the surface of the Earth. These wells, called production wells, bring the superheated fluid to the Earth's surface, where it can be used to generate electricity for homes and businesses.
So what is so neat about this? We already have electricity.
Well, Brittany, geothermal power has several positive qualities to it. The first is that geothermal power has the potential to produce power all year round, nearly 95% of the time. This is comparable to coal power and gives geothermal the potential to be a baseline power producer. If you compare this to wind and solar, they only have utilizations around 30 to 40%, since the wind is not always blowing and the sun is not always shining. This makes them better suited for peak power production. Secondly, there is very little pollution involved in geothermal power. There is no carbon dioxide being released to the atmosphere and no fossil fuels being burnt. Most of the water that is brought up from deep within the Earth is put back where it came from. Finally, there is very minimal environmental impacts involved with geothermal power. There is very low space required for drilling operations and very low freshwater requirements. However, there are several downfalls to conventional geothermal power. The first is that it's not available everywhere. Geothermal power is usually found around borders of the tectonic plates, so the ring of fire in places like California, Alaska, Australia, and Indonesia are hotspots for geothermal power. There are also several large development costs that dissuade developers from going after geothermal projects. It's virtually impossible to get loans from banks for the development costs due to the high amount of risk involved in exploiting the resource. In order to determine whether or not an area has a solid geothermal reservoir in place, $20 to $30 million must be spent in drilling and in exploration costs.
What is EGS?
EGS, or an Enhanced Geothermal System, is a man-made geothermal reservoir. Throughout the world, the bottommost geologic layer is a layer of bedrock, often referred to as hot dry rock, which is usually granite. The idea of EGS is to drill 2 wells into this granite and crack it enough so that water can be pumped from one well to another through these cracks, heating the water up as it goes. This image shows 1 injection well pumping cold water into the resource and 2 production wells bringing the now heated water to the surface. The heated water is taken to a power plant and electricity is produced the same way as in conventional geothermal systems.
So why is this any better than conventional geothermal systems? Sounds like more work.
You're right, Brittany. But since hot dry rock can be found anywhere on Earth if drilled deep enough, this resource is widely available. This also eliminates risk in searching for available in-place reservoirs, since you know that you're going to find a reservoir. There are also massive amounts of power available using EGS.
Please see video 2 and 3 for the impact this technology could have on your life.